Hello, everybody. I hope I will not finish you up with my heavy concepts, and it's end of the day and end of the conference, so try to keep it as simple as I can, but there is some problem in academic circles. We usually, when they try to do this, we get starting to say more complicated stuff. Here I'm representing, can I take this in the hand? Here I'm representing the VivaGrass project. It's the project, complicated project in the which I try to talk further, but in the basic, to bring ecological knowledge to the planning and somehow to build this bridge, and GIS tools are the ones we use to build. And we will see how successful we are. So first I will introduce you with the ecosystem service concept, then a little bit spatial planning and GIS tools. And then I try to tell about the VivaGrass tool, the tool we created during this project, decision support tool, and different models of it and the structure of it. So, ecosystem service concept is that the ecosystem service is the thing somehow quantify the phenomena derived from the ecosystem concept. So, to put it more simple as I can, it's just the various benefits, goods and services that certain ecosystems provide us. And to be clear, like any, when we look at the, for example, land use as we are used to do it in GIS, if we can delineate certain land use, then we can call it ecosystem. So any land use could be an ecosystem. And in our project, we concentrated on agroecosystems, and this is just a farmland. So to be more specific, what are those services? And those are like usually divided in three parts. The ones are provisioning services, which are more tangible and which we usually understand as the production. It's certain food, wood, and fuel. Then it's something that's not so easy to grasp, but way much more important than the previous ones, because they're regulating services, the services which allow to all the human system to work. It's usually the most famous are the climate regulation nowadays, and the flood regulation, water purification, and different processes in the soil. And then there is a cultural services, which we deal with recreational and aesthetic values. So ecosystem service concept is kind of ecological concept with an economic approach, but don't get me wrong, it's not that we put certain value, monetary value to the services the ecosystem provides us, but it's rather that to account for them, for the managing and for planning them. So basically, there's a lot of services which constitutes human well-being, and whenever we plan something, whenever we implement our decisions into the environment, we should be aware that what they're bringing to the well-being of humans. It's probably not the right audience to tell, but I will point out once again that why GIS is so good for analyzing ecosystem services. And first of all, the provision of those services are having like strong spatial nature. The ecosystem functions and processes which are responsible for the provisioning of the services, they vary in the time and space and are scale dependent. And drivers that affect and change and modify the systems have a stronger spatial variation. So as I bolded out, those spatial nature, variability in time and space, and scale dependency. So it's exactly three things what we use GIS for. And as you know, that's like a landscape ecology, which I'm representing here, and GIS are just part from the system science, so it's easy to work together. Just sometimes we don't find a common language, but that's a minor thing. So in spatial planning, the ecosystem service concept is very novel. Nevertheless, already in Estonia, it's inside the planning law. So all the spatial decisions or the planning process should account how we change the ecosystem services, and I'm pretty sure that both in Latvia and Lithuania, and soon they're going to be implemented. There are a lot of tools for this purpose. Most of them are somehow connected with GIS and has a spatial. The results could be spatially produced in the maps. And one of the famous is mostly Invest tool, which works as a plugin of ArcGIS, but yeah, it has a special background. It was hard to use for our conditions, and but anyway, there's a lot of them, but none of them are aimed at planning at the certain special level which we were aiming our decision support tool. So to plan a land use for certain field, plot, to realize, to show how appropriate is certain land use towards the agroecological conditions. And this could be expressed by this understanding what services and in what intensity are provided. Very easy to implement inside the GIS is this multi-criteria decision support, is this scheme we use for all the planning processes. And this tool which we created, it's like it's present in every time, and it's it provides this kind of way to talk to the stakeholders. It's both the people, the policy makers, the corporate bodies, and others. So we should remember that the GIS on its own, without interaction, could produce not so good results. So the Life VivaGrass project was aimed to analyze synergies and trade-offs or shortcomings in land use and nature conservation policy, and try to offer integrated and ecosystem-based planning solutions. And specifically, we try to emphasize the viable grassland management, because the grasslands are the agroecosystems which are threatened, which are most threatened in our region. The project is the Baltic State project, and it consisted both of universities, NGOs, and programmers from Mid-Baltic. So here you see the basic structure of the tool. We created 3 modules, which are where the user interacts. Then there is a not seen side of the iceberg, which is actually bigger than I draw here, and which consists of information and data products. And the one nice thing we call a link module, which is a plug to connect to any other system. As we saw in today's presentation, that there's a lot of tools which kind of work on the same logic. So at some point, I hope it could be easily to create one super tool, but just to see how much of artificial intelligence we would allow for this tool to implement. So what we do, we assess conditions, we analyze those conditions. And then from those from the results of the analysis, we could evaluate certain developments. We took it very serious as it's usually getting into troubles to communicate it, so people should, I mean the planners and the policymakers should get used to the concept and use just to the representation of it. Then the special purpose project, it was the bioenergy model, which really for the special purposes of managing the grasslands, and this is more connected to the demands of Estonian side, is where the grass, mown grass was used, could be used as a source for heating. So it analyzes the calorific power, it analyzes the demands and the distances to the plants and how to connect all those. And for the specialists, for the planners, we had a VivaGrass planner model, which is a decision support system actually, which is this end product where we gather all the knowledge and all the analysis done and shown in the viewer, and also in bioenergy model to get directly to the planner the concentrated information with additional layers and anything what the planner could be needed, what he would need it for his planning decisions. It's a bit complicated, and for this we created also online learning tool and doing the tours around the country to teach the people to use it. And yeah, I didn't mention that, I get into this GIS, forgetting to mention that it's, I think as all previous tools is based on this ArcGIS enterprise platform. The data is stored in the common spatial database as maps and published as GIS services and maps, and web applications are constructed also in the ArcGIS web application builder. So I would like to encourage you to, especially the ones who are somehow connected to, who are planners and doing the planning, to visit our site, the project site, it's VivaGrass EU, and then you go to integrated planning, and then there's a viewer model where you can see that and learn on the ecosystem services and see their distribution in agricultural lands. So we use the land use data from the IX database, and this already is a composition of underneath layers you don't see. It's soil quality, soil type, and relief. So we calculate in the overlay certain categories which later the experts assess as in ecosystem service values, and from this we could get ecosystem services, for example, bioremediation. I will not even try to explain you. But there is a lot of services which is easier to understand, as, for example, biomass energy sources. So by simple scale, we see certain plots, we see their potential, and of course, it's very variable of the depending on the season, on the climate, but this what we mapped, it's this like supply potential. important services, this maintaining habitats, so you will see how the field is suitable for species, to maintain habitats for different species. And also we map such things as the cultural services, which is hard to, it's very process with a lot of work inside, so we map it only for project areas and very slowly extend to the whole territory. So it's this aesthetic value, educational value, recreational value. It's a lot of indicators inside, and I will not go into the details. But through this, all the analysis we have done inside, we have created certain matrix, certain algorithm. So people could see that what opportunities ecosystem service concept could bring us. And my favorites are the trade-offs. The trade-offs, as we all know in the planning, we should eliminate trade-offs, we should strengthen the synergies. But where exactly they are? And as this tool aims in exactly at the plot level, at the smallest level to make a decision, we could easily see that there's a trade-off in which direction. So this means that those plots highlighted here are having a lot of production associated ecosystem services and really lacking habitat management or habitat sustaining ecosystem services. It could be otherwise also. So these plots are really producing a lot of services or supplying a lot of services which are connected with the habitat, and there are certain shortcomings into production. So for the decision maker, it's a clear thing. So if we want those fields to go on like this, so this production or lack of the production should be compensated somehow. And then there is a lot of ways to do it through the rural policies, through the rural tourism, and like to make it multifunctional. And the opposite way also is the ones, for example, where it's losing the habitat value. So those are the territories where the planner could push up towards the probably green infrastructure or other implementations which would decrease this or move a little bit this trade-off towards the synergetical side. And yeah, and the one, my favorite, is the cold spots and hotspots. But you should take in mind that this is not the cold spot, hotspot thing that you produce in ArcGIS. In ecosystem service concept, it's a little bit different. And so it's somehow parallel, and now we have a collision. So here we see that the fields which are, we see how many in which value the ecosystem services are supplied. So to get a better picture, we could go to the fertile grounds of Zemgale near the Lithuanian border, and you would see that it's quite bad. It's quite cold. It's but as a preliminary studies show that most of the territories where the agriculture is dominating in all three countries, it's showing certain shortages in providing ecosystem services connected with habitat maintenance and nurturing the species. But where you see, for example, the blue ones, those are the coldest ones. It means usually that they are agricultural land on organic soils. So it means that it's not only creating, it's not only lacking space for the habitats and the species, but it really also doing a harm to our climate conditions. So it means like when you plough the organic soils, a lot of carbon goes up. And Yeah, I think that's it. I will not bother you anymore with more ecology, but you should keep in mind, I think maybe some, that whenever we develop tools, we are very good at this scientific part, but we always have to plan that how they are be user friendly for ordinary people, not common with the GIS and a specific way of understanding data structures. So should always this should be an integral part, in my opinion, that whenever the GIS is in the accessible tools, like for general public, it should be somehow planned for the interaction with the common users. Thank you.
Thank you. I understood that behind there are a lot of analyses, yes?
Yes.
And models might be, or not?
Sorry?
There are models, or just, what, is there any models behind?
Yeah, at this in the viewer, no, this is static data, but in the planner, which is like personal data, of course, yes, it's a lot inside, but we are not ready to show it at this moment.
Okay, next time.
Yes.
So, thank you.